What specific problem does the self-challenging agent framework aim to solve in the context of training LLM agents?
The Self-Challenging Agent (SCA) framework aims to address the challenge of generating high-quality synthetic tasks for training large language model (LLM) agents in open-ended and tool-rich environments. Traditional task creation methods rely on human annotators, which are costly and not scalable, leading to a need for an automated pipeline. The SCA framework introduces a dual-role approach where the agent first acts as a challenger to explore the environment and generate feasible, verifiable, and challenging tasks using the code-as-task (CAT) formalism. This formalism ensures that each task includes an instruction, a verification function, an example solution, and failure cases, thereby enhancing task quality and reducing noise in the training data. Ultimately, the SCA framework enables LLM agents to self-synthesize tasks and improve their performance through reinforcement learning without the dependency on pre-existing annotated tasks.
How does the proposed self-challenging agent method work? Illustrate step by step, particularly focusing on the roles of the challenger and executor agents as well as the code-as-task formalism.
The proposed self-challenging agent (SCA) method operates through a two-step process involving distinct roles for the agent, the challenger and the executor. First, in the challenger role, the agent interacts with an unknown environment using various tools to gather information and generate synthetic tasks. This process culminates in the creation of tasks formatted according to the code-as-task (CAT) formalism, which includes an instruction, a verification function, an example solution, and enumerated failure cases, ensuring that tasks are feasible, verifiable, and challenging. Next, in the executor role, the same agent attempts to accomplish the generated tasks by executing actions in the environment, utilizing the verification function to assess success and receive rewards. This structured approach not only enhances the quality of the tasks generated, but also allows the agent to learn effectively from its own synthetic tasks, thereby improving its performance in real-world scenarios.
Can you provide a simple yet illustrative example of how a task is generated through the self-challenging process? Walk through the main algorithm steps using a specific example of a task.
In the self-challenging agent (SCA) framework, a task is generated through a two-step process involving a task challenger and a task executor. For example, consider a task where the goal is to book a flight from New York to Los Angeles. First, the task challenger interacts with the environment, using available tools to gather information about flight options and requirements. It then synthesizes a task specification in the code-as-task (CAT) format, which includes an instruction, book a flight from New York to Los Angeles, a verification function that checks if the flight booking was successful, an example solution that outlines the steps taken to book the flight, and enumerated failure cases, e.g., flight not available or insufficient funds. After generating this task, the task executor attempts to complete it by following the provided instructions and utilizing the verification function to assess success. This structured approach ensures that the generated task is feasible, verifiable, and appropriately challenging for the LLM agent.
What are the theoretical and practical benefits of using the self-challenging agent framework compared to traditional methods for training LLMs?
The self-challenging agent (SCA) framework offers significant theoretical and practical benefits over traditional methods for training large language models (LLMs). Theoretically, SCA introduces the code-as-task (CAT) formalism, which ensures that generated tasks are feasible, verifiable, and challenging by incorporating structured components such as instructions, verification functions, example solutions, and failure cases. This structured approach mitigates the risks of low-quality tasks that can contaminate the training process, a common issue in traditional task generation methods. Practically, SCA enables LLMs to autonomously synthesize high-quality tasks through interaction with their environment, leading to improved performance in both self-improvement and distillation settings, as evidenced by a 22% improvement in success rates without existing tasks. Additionally, SCA outperforms prior state-of-the-art methods, such as the Proposer Agent Evaluator (PA), particularly in partially observable environments, demonstrating its effectiveness in generating precise tasks that enhance the learning process. Overall, SCA's ability to automate task generation and ensure task quality represents a significant advancement in training methodologies for LLMs.
How was the self-challenging agent framework validated or tested in the experiments? What metrics and datasets were used to demonstrate its effectiveness?
The self-challenging agent (SCA) framework was validated through experiments conducted in two multi-turn tool-use LLM agent benchmarks, specifically MCube-Tool-Eval and Tau-Bench, which included tasks from 4 different environments. The effectiveness of the SCA framework was demonstrated using metrics such as the average success rate, measured in terms of pass at 1 and pass at 4, across various environments. In the distillation setting, the SCA framework improved the student model LLAMA3, 1-8B instruct by 22% in absolute average success rate, while in the self-improvement setting it doubled the success rate from 12.0% to 23.5%. The experiments compared SCA against several baselines, including the Proposer Agent Evaluator, PEI, highlighting SCA's superior performance, particularly in partially observable environments. Additionally, the experiments included ablation studies to analyze the impact of different components of the code as task, CAT, formalism on task quality and performance.
What are the limitations or drawbacks identified in the paper regarding the self-challenging framework, and what potential future work is suggested to address these limitations?
The paper identifies several limitations of the self-challenging framework, particularly concerning the presence of false negatives, FNs, in the generated tasks, which arise from semantic nuances such as ambiguity or missing information. This issue leads to a suboptimality gap between the RL training with SCA tasks and ideal Oracle tasks. Additionally, the framework tends to enhance environment-specific skills rather than overall agentic capabilities, indicating a limitation in generalization across different environments. To address these limitations, the paper suggests future research opportunities focused on improving the task generation process to minimize FNs and exploring methods to enhance the environment general agentic capabilities of LLM agents.